So the title of our recent research work is Computer Vision Algorithm for the detection of fracture cracks in oil hardening, non-shrinking, die steel automachining process. So in this work, we have employed a unit algorithm, which is a type of convolutional neural network, which is a variant of neural network for processing with images. So this type of neural network receives an input from image and extracts features from the image while also providing learnable parameters to effectively do the classification. So we have simulated our code in Jupyter platform by using Python programming, and the results showed that the fracture cracks can be validated by testing with higher accuracy. Now moving to the experimental part. So in the present work, the unit algorithm is used for the identification of fracture cracks present in the macrostructure images. So first, here, so the first step is to collect the macrostructure images. So the macrostructure images were collected by using scanning electron microscopy, and then for each, so after collecting the macrostructure images, we had divided the images into two folders. First one is training folder, and other folder is testing folder. Now, for in the training folder, we create two subfolders. First subfolder contains the original microstructure images. And the second subfolder contains the masks of the original microstructure images. So this mask is created by the canny at detection algorithm. So the unit approach has various benefits for segmentation tasks, starting with the simultaneous use of the central place and context. Second, it performs better for segmentation tasks, even with smaller number of training datasets. The network has U-shaped architecture because it has a both constructing path and expandable path. The contractive path is a standard convolution network that applies convolutions repeatedly, followed by rectified linear units and max pooling operations of each one. And we have further used accuracy versus number of epochs curve and loss versus number of epochs curve for the evaluation purpose. Now, the performance evaluation of the framework was carried out by these graphs, that is by loss function and accuracy evaluation. One of the most crucial components of neural networks is the loss function, which together with the optimization function is directly in charge of fitting the model to the provided training data. A loss function analyzes how effectively the neural network models the training data by comparing the target and the predicted output values. Now we try to reduce the difference in output and the predicted and the target during training. Now, the loss function is calculated. Let me so this is the equation, but let me write it in a good format. Okay, so we can calculate the loss function by this equation, J, which is the function of W power T, and B, which is equal to 1 by M, summation of I equal to 1 over M. loss function. This is the predicted value and this is the actual value. So here we discover the weights, that is this is the weights, this is the bias, and that minimize the magnitude of J after adjusting the hyperparameters to minimize the average loss, which is indicated in this equation. Now moving to the result and discussion part. Let me have this. Okay. From this plot, we observe that the so we observe that here the loss function decreases loss function for both training and testing part decreases with number of epochs. Now, if we observe the accuracy curve, we can see that the accuracy score for both training and testing part increases and it goes towards 1.0. So we can say that our levels is 100% actually segmented or can be labeled with higher accuracy. Now moving to the conclusion part. So by this research work, we have achieved the goal of image segmentation to separate an image into a number of smaller pieces, and the completion of each object segmentation will be added by these segments or the numerous segments that we have formed. Now the future scope of this work can be implementation of the embedded machine learning, or we can call tiny ML, to concatenate our framework and with some software development like an app development for real-time monitoring of the fracture by a normal human operator. So thank you.